Hello, PreCalc. Wednesday's edition. We're looking at this after Wednesday's class. It's the 30th of November already. So we're steaming along through this year. Don't blink or it'll be all over. Alright, so here are the expressions we learned for the sine and the cosine for a sum and a difference. And they were worked out for us in the video previous. So now we're going to actually use that information, and to do that we have to evaluate some things that we already know, and these will help us know a whole lot more. So I'm kind of getting into the why we're learning these, and make sure they're in your comp book, in the body of it, and also in the section where you're gathering your trig IDs and other formulas. So on the unit circle, we know quite a few expressions. Let me see, I had a list of them. Where did my list go? And also let me start my timer. Timer set. I'll do 13. Alright. Here we go. There are some trig expressions that we know the sine, the cosine, and the tangent for. Of course, we know the other three trig functions for these as well, but these are the ones that usually come out to play. And we know the sine, cosine, and tangent for any spot on the unit circle. So let's gather what those are. So we know 0 degrees, 30, 45. So I'm just thinking around the unit circle, all the values that I'm used to using that are marked on the unit circle, which I know the values for. So this takes me halfway around the circle, and I have the monkey math in there. I have the sixths, and I have the quarters. So I think this is all of them. And then if I come around the rest of the circle, I would have 210, 225. So get these down. You can look at your unit circle and get them. You can just jot them down as I do. So I'm just kind of borrowing from my mental unit circle. Alright, so I went all the way around and got all the degree measures. Now I'm going to also list the radian measures, as they also will be helpful. So 0 degrees is 0 radians, 30 is pi over 6, and off we go around the circle again. Alright, there's the radian measures for those angles. And at 210 we're what? 7 pi over 6, then 5 pi. Remember those days when radian measure was an odd thing? Now I have trouble working in degrees sometimes. Who knew? Alright, so here's the equivalent degrees and the radian counterparts. Alright, so let me draw a little line here. Alright, so I already know sine, cosine, and tangent for all of those. So you would think that'd be quite snazzy, but it's not snazzy enough. So these expressions up here will open a whole new world of snazzy to us. So let's see what I'm talking about. Now you can, without a calculator, so if some of our enemies sends an electronic cloud and it cancels out all computer and calculator activities, we will come to the rescue, and they can pay us big bucks to tell them what is the cosine of 75 without a calculator and without it being on the unit circle by using the above expressions. The way we do that is we are going to rewrite 75 as a sum or a difference of any two numbers in this list. I'll go ahead and use degrees because this problem came to us in degrees. If it came to us in radians, we would use radians. So I can quickly see that I could add 30 and 45 to get 75. So I take two that I know and I'm going to add or subtract them to get the exact expression. So what I'm going to come up with the cosine of 75 is no demonic decimal. No, no, no. It is an exact answer. So decimals are an approximation. So we're going way beyond. All right, so this we notice is the cosine of a sum, which we see in this line right here. So the cosine of a plus b, so my a is 30 and my b is 45. So I'm just going to use the above formula of the sum, cosine of a sum, and plug in those values. So cosine of a plus b, I'll rewrite this, you probably will skip this step, but while we're in the learning phase, no detail is too much. All right, so I rewrote the sum. I recognize that I'm using the sum, a cosine of a sum. Here is the expression. My a is 30. My b is 45. So when I do that, you'll see that 30 and 45 will give me the desired 75. And following the formula, wherever there's an a, I put a 30. And wherever there is a b, I put a 45. All right, so following the formula, I get that. So these are ones that I do know. So let me get a little bitty unit circle going here somewhere. There's a room right here on this edge. All right, living on the edge. Let's go ahead and put in, we're going to need 30 and 45. So 30 is right here. And that is square root of 3 over 2 over and 1/2 up. Sorry, I didn't leave myself enough room. And up here we have, we want in between at 45 because that shows up. That's square root of 2 over 2, square root of 2 over 2. All right, that doesn't show up well, but you know what it should be. Make it clear for yourself. So I'm going to get cosine of 75 equals cosine of 30, looking at 30 degrees, which is our old pi over 6. I see that the cosine is the first coordinate, square root of 3 over 2, times the cosine of 45, which is square root of 2 over 2. Now I hit the minus sign. Sine of 30, second coordinate, 1/2. Sine of 45, second coordinate, square root of 2 over 2. All right, let's clean it up a little bit. Cosine of 75 equals, we're going to multiply the radicals, square root of 3 times square root of 2. That's a missing thing, so prove to me that you are well taught. The bottom times the bottom, I'll do. The top times the top is square root of 6. All right, and then over here we get top times top. Numerators, their product is square root of 2, and the bottom is 4. If it doesn't have a like denominator, give it one. This happens to have a like denominator, so I get square root of 6 minus square root of 2 over 4. That, my friends, is the cosine of 75 degrees exact. No approximation about it. So That is the exact one. And so look at that. Cosine of 75 before we couldn't do without a calculator, and now we can. Sometimes I will ask you to go the other way. So let me put these down here so you can see them better. And I will give you one that looks like this. Sine of 42 cosine 12 minus cosine 42 sine 12. And I'm already on this side of the expression, and I'm asking you to go to this side. So I'm asking you to simplify that. And you can notice that this pattern is sine cosine minus cosine sine. So it's like this one. So going up to the one that I just checked, we can see that that equals, I'll write it underneath, sine A cosine B minus cosine A sine B equals, I'm writing it backwards because we're already on this side, and it equals sine of A minus B. Alright, so I recognize my A is 42 and my B is 12. So again, a lot of this you won't really have to write out except during this learning phase. So substituting in, my A is 42 and my B is 12. I'm going to get, that equals the sine of A, identified as 42, minus B, identified as 12. And what does that equal? 42 minus 12 is sine of 30, a dear old friend of ours from the unit circle. And that is the second coordinate at the 30-degree mark, and that is 1/2. All right, so that is the simplified answer, the simplified answer for this expression. Double snazzy. All right, we'll end tonight by adding 2 more to this list. So, all right. I'll do one and you do one. So I do, you do. It's a nice game, don't you think? I do. All right, what I'm going to develop now is the tangent of a sum. And I'm going to do that because as soon as I wrote that, I saw Dan's thought cloud. And he was thinking, well, tangent of theta is sine of theta over cosine of theta. And that's in our most recent memory work, and we've used it many times. So tangent of A plus B can be rewritten as sine of A plus B divided by cosine of A plus B. So what did I just do? I used Dan's relationship here where he noticed or remembered that tangent is sine over cosine. So tangent of this is sine of this over cosine of this. So, but these two I know because they are on my list. So looking at my list, I can replace sine of A plus B with this expression. So I will do that right now. Sine A is not the sine of a sum. Sine A cosine B plus cosine A sine B, is it not? And then cosine of A plus B will follow this expression. So we get cosine A cosine B minus sine A sine B. All right. I'm almost done, but the timer went off, so I will switch off to part 2. You love part 2s, admit it, admit it. All right, over and out for this part, and I'll be right back.